Cube. So here we go.
Hello, good evening. I hope you're having a nice evening. And in this case, I want to share with you that perhaps the presentation, in order that you don't see just the slide and you see me and it's a bit better, I'm sharing here a URL for a YouTube streaming that we are doing right now in parallel with this. So the idea is that I will do the presentation over there, and this way you have a much better experience on this. I don't know if you have any problem with the URL. You just tell me, and then we start. And thank you, Jason, for the invitation to talk here. I'm also with Professor Gabriel Huecas. I don't know if you see anyone is in the streaming.
Hi.
Have you all managed to see the streaming? Yes, no, abort, retry, ignore.
Perhaps there is no channel.
Sorry. Oh, okay. Okay. So if everyone. Okay, thanks. So I will go to make the presentation, and even I am going to do it. You can interrupt me anytime, no problem on this, and we start doing the presentation. Oh, I mean, okay. Oops. I have a problem here with the GoToMeeting. Just a second. I'll put it over there. Okay. So our talk today will be about the Impact Growth Accelerator webinar on the core context management. As you know, the core context management is the one that is taking care of the NGSI standard. And with this, we have several ways of handling this kind of things. Most of them are, in our case, is related to also big data analysis. In order that you can perform all kind of analysis, or also complex event processing or whatever, you can use the tools that we are going to introduce you. There are several ways of doing right now analytics, MapReduce, in-core memory, etc. Or most of them need the data. Some of them need the data in a batch. This means that we have to have everything stored in some place. But the advantage is that in some moments we need, or we are able to handle data in real time. This means that we can have some kind of fast data architecture, what it was called a year ago, and in this case it is something like an Aeon. It was called the Lambda architecture and things related to this. So you see our FIWARE infrastructure. We have the context broker. They are connected to some strange component that is called Cygnus, that will take care of all the kind of interaction that we want to do with the other way around. Here you have the Cygnus, and you will have also connection with the big data and also with the short-term historic that is over there. This is quite related to the context broker that is over here. I look like the one that make the weather show. Sorry for this, but so here we have the context broker, that is the Orion, that is the one that will take care of everything. In parallel, we have here CCAN, and also we have over here the EOT, or the one that processes this kind of things. You can use then complex event processing. Even now, we are adding also in big data Apache Flink that will take care also of the complex events processing. Over top of it, we have all the applications that we have. We work with this. Can work with the data from the context broker or the data that we provide with the components that we are going to talk about. Well, the usual joke, we are going beyond Orion, so you have seen a lot of things in Orion, and beyond Orion, you know the Tannhauser gates and this kind of freaky jokes. So we are focusing on the NGSI. The NGSI is the standard that we have. It's quite relevant because it's not only the serialization of the data, you can do it with JSON. Here we have the semantic of the data. This is quite important because up to now, none of the standard has taken care of this. Even is ongoing, something that is related to NGSI LD, where we have RDF and all the power of the semantic web. This will come very soon. So we have three components that take care of the NGSI subscriptions. We have the last value. This is the Oreo Context Broker. Probably you have done a lot to the work with it. You can handle all the registration and all the events, and when everything changes, you get an event and you know what is happening. But the idea is that the Oreo Context Broker has just the last value, or perhaps the last value, depends on the implementation. This means that if you want to know exactly what it has right now, you have to use the Oreo Context Broker. But if you want to have an historical, we have two solutions. One solution that is packed in one single program, that is the common STH, the short-term historic, that keeps a small historic log of the different value that you have in the context broker. Also have some queries that can do aggregation. We will see about it later. But for example, if you're monitoring the temperature in a room, with the Oreo context broker, you have the temperature that the sensor is saying that is happening right now. With a short-term historic, depending on the size, you can have the values for the last month, for example, and you can ask it for the mean value. This means that not only gives you the raw historic, but it's able also of doing some application over there. So simple applications or simple aggregation operations can be done with the comment. And if you want to use all the historic, there you have Cygnus. There you can connect everything to different databases, even at the same time. We will see this later. You don't need to connect to a single database. You can make events filtering and decide that some events can go to one or another. Even there is a work going on to have a serialization even on blockchain. So I will introduce a bit about the STH-Comet. The presentation has a lot of slides, but since we are in a short time, I just will present the main ones. I will leave it to you later in order you can use for reference. And as I said before, we can have a small session next week where Andres, that could not be here today, can solve you all the problems on how to start everything with Docker and these kind of things. So as we said before, the context broker just gets the last value, and the short-term historic gets the last ones. Not all of them is limited in capacity, but the advantage is it's very simple to use and very simple to install components. It's a self-contained application that basically is an ODS web server that takes care of the NGSI registration with the Orion, and also MongoDB database that will keep everything over there. So we have some kind of time series database where we have different things. We have raw data. We can get, as I tell you, give me the last values for the temperature in a room in last week, and we get a series of them. Or we can have also some kind of aggregation. We can have pagination, and also all the things that you usually have in this kind of databases or in web applications. Probably most of you are used to this kind of things. It's built with a REST API. This REST API is quite flexible, allows you a lot of things, and allows you to do several things on this. So how it works? I mean, you can ask, instead of asking things to the Oreo Context Broker, you just handle Cygnus or another component. Even you can connect directly. Here we have just the Cygnus solution, but it's not needed. You can connect directly to MongoDB. What you will get is that we can connect and have a different subscription to the context that you have in an Oreo Context Broker. You cannot get rid of Oreo Context Brokers. It is the key of the old architecture. What we are saying is the different things that you can connect to an Oreo Context Broker. So the Oreo Context Broker, we talk via Cygnus or directly with STH-Comet, and we serialize everything on the MongoDB database. So you as a client, from this moment, once you have set up this with the usual registrations, the registration is the same one that you are using the Oreo Context Broker, you can start querying the REST API that STH-Comet is offering. This solution is not for everyone, but I think that can solve a lot of problems. If you don't want to have a complex Cygnus installation, that we will see later that we can do, you can use it in a very simple way. Use these components, and if your problem matches what we are offering here, I say the last values, then you have everything solved. Even we can make it without Cygnus, and we can have the connection directly to the context blocker. This is the most simple scenario that probably if you want to not get full serialization or later do some kind of complex big data analysis or something similar, this will be more easy. So you just need the STH-Comet, your application, and the context broker. Take into account that from this moment, you don't need to query the context broker. You just query the STH-Comet. This perhaps simplify your architecture depending on the problem that you have. We can talk about this later in the questions time. As I tell you, it's developed using a web server, Happy, that is built upon Node.js, and we have a MongoDB optimized for time series way of working. In principle, the MongoDB database is not exposed. This means that if you want to have your own MongoDB solution, you probably need to have a direct connection via Cygnus. But in some cases, you can access to this MongoDB. I mean, it's not protected. It's protected, but I mean, if you are in control of everything, you can get access to it, and you can get all the things you have. I'm not mentioning here the security that probably you have explanation on this, but if you want to secure this, you have to put the PEP proxy that is called Vilma here, and everything will be secure. I'm just talking about this part, and so I don't take into account the security. But take into account that if you want to do a DR deployment, you need the part that is related to the other things. So here we have different data schemas, and also we have different pre-aggregations on this. So you are able not only to give the raw data, but also different way of giving these things. So as I tell you, give me the maximum in that happens in last weeks, probably at least in Spain is today. It's quite hot here. Or give me the main value for today, or give it a range. I mean, you can do a lot of simple queries. It's not pretended to have complex queries. If you want to have queries more complex than this, you have to program them in using Cygnus. But we have a very good, let's say, set of aggregations that probably solve, let's say, the 80 or the 90% of the problems. So we can have different things, and we have here some numeric pre-aggregation, so we can have some different values. Everything is serialized in JSON, so you can comment and get here. Since we are having a REST API, we have here just the way to get the connection. Here we have this is the REST API. We can connect to the entities. Here we have the entities type and name, that is the one that you have in the Orion context broker. And after this, we will get receiving the solution here. Also, if you want to have everything secure, you need to add the security token. You can have pagination. If we are querying for a big amount of data, you need to do some kind of pagination. Here we have the different response. So you have here the name and the attributes, and here you have the different values and the different responses. We can ask for aggregated data. The previous one were for some data, and here I'm saying that they want just the assume, that's it, the added values from one date to another date. And this means that we will get this, and here the solution, just instead of be a series of values, it's just one value, that is the mean value. Well, it's not the mean, it's the assume, but you get the different responses. You can remove the data if you think that the data in some moment is not the right one. You can ask for removing. You can connect this with different kind of logging services, so in order you can, depends on the infrastructure, you can handle these different types of logs. And there we have this solution. The other solution, as I tell you, is Cygnus. Cygnus is completely different. It's not more complex, but since it's very, very configurable, means that we have a very simple configuration that probably you need to change. The advantage of the STH-Comet is that you don't have to do any configuration on this. You install it. I don't remember right now if it's just one Docker container or two, but you install it and you start querying the REST API, and you don't need to do anything. The advantages of Cygnus is that we are right now adding all the things you need for a fast data architecture. This means that we'll be more flexible and will allow a lot of things. Inside of it, it just have a pub subscribe-like communication model. It's not real pub subscribe. It's just a metaphor in order that you can, let's say, program the work it is. So it will get, in this pub subscribe mode, different context broker notifications, and it can serialize to different syncs, what is called syncs. The syncs will be usually the persistent layer that could be, depending on the architecture, different databases. You can connect one or more. Why is this? Because probably you cannot have one single type of data. Perhaps you have data from users and you want to send this to a relational database. You have a lot of historical data and you want to say to Mongo, to Cassandra, or to wherever. Perhaps you have graph information and want to send to a graph database. Or you want to do big data and you want to send it to an HDFS storage system. Everything could be done at the same time. You don't have to choose. I mean, one Cygnus can connect to several databases at the same time, and even we can filter the events. They decide that one event have to go to one point, or the events can go to another. We'll have, I guess, some definitions. So the main architecture is the one that we have here. So in this case, we can have a web server or the Orion Context Broker. Inside Cygnus, we define these entities. These are not real entities. I mean, there is no communication, so the latency is quite low. And we define something that is called source. The different sources will go to one or more channels, and we define one or more syncs. The trick of having channels is what I told you before. You can filter whatever you receive from the events. The same events can connect to several channels. These channels can filter what they send to the syncs or not, and you can have several syncs. You can have several syncs with the same information if they are connected to the same channel, or via different channels we can connect to different syncs, sending different information. This means that this is very, very configurable, but this also means that in some cases have an extra layer of complexity installing everything. It's not too much. You can install our component in several ways. We have the most usual configurations ready. So if you don't want to do anything quite complex, you can do it. And it's quite simple to do it. Don't worry, it's not really complex. Right now, we are having a lot of connections. We can connect, if you want to do big data, with the HDFS. We are having support for the more used relational database in most applications, that is MySQL. If you want to publish open data, that is also connected to the market, you can serialize this to CCAN, MongoDB that we are using here. Even you can connect to an STH-Comet. I mean, this is compatible. You can have Cygnus and STH-Comet. With Cygnus, you capture everything. You still can have STH-Comet and main communications with it. We have already provided connectors to Kafka. This way, you can make pull subscribe depending on the infrastructure. You can connect also with DynamoDB, with PostgreSQL, CartoDB, Cassandra, and now we are working on a blockchain connector. Also, we have some experiment with Twitter, but well, this is something that probably you don't need. Here we have some examples, and what we have here is the model. As I told you before, the model is that I provide a source, later I provide a channel, and later I provide a sync. These are defined here in a text file. The text file is the configuration file. We provide simple for this. And what you declare here is that you have a source, a sync, and a channel. This is the simpler configuration, where the source just take connection from HTTP and the port 5050. the sync is a simple one, and that could be the STH database, and the channel is whatever, just let pass everything. So you just have to provide this connection, and depending on the things that you want to have, you have to install the required database or the required system that you are willing to use. As I tell you, we can help you with the different connections. We have a lot of examples, and we can guide you on this. For example, if you want to send information to multiple backends, this is I told you before, you just define a single source, that is the one that will be connected to a web or will be connected to the Orion Context Broker. We define 3 channels, and these 3 channels, what is sending are the events and the NGSI information to 3 different things. The 3 different things could be 3 different databases for 3 different purposes. For example, HDFS for big data, a relational one for some information, and a NoSQL one for some other queries. In principle, the channels are transparent. I mean, they provide all the events from one side to another, but you can use some filtering. I mean, that some channels can provide to the thing they are connected, not all the events they are receiving, but just the one that fulfills some kind of predicate. They are also, since this run inside a Java virtual machine, and this means one Unix process, if you are having a lot of traffic, you probably, instead of having this thing, you need to do this kind of the instance. This instance, we have 3 processes, 3 different Java machines, and this means that the performance for this is quite much better. In other cases, you need to provide 3 containers, or you need to provide 3 virtual machines, or 3 different machines in your network. Probably these are required for a very, very high throughput, and you are none of you facing this kind of problem. Probably the previous before is the one that can work here. So we just have to connect the Orion Context Broker in the usual way. You just register and subscribe to some of the events, and once the events are flowing, they flow through the connection, through the configure file that you provide, and they are all in serial. This means that Cygnus didn't have any kind of processing, just can filter the thing, decide where to send, and you later have to use another tool. In the big data part, we provide some tools, we can probably will see another day, and there you can do these things to work with the data that you have in the different databases. So Cygnus is not intended for processing. In the previous case, STH-Comet already have some simple processing. And here, since you are expected to have more complex processing, it will have different tools for this. And you can use any tool that is able to read information from the database that you send whatever information you want. Here we have a simple connection. For example, here is the same that I put before, but now we connect to the context broker that inside an HTTP source and says to memory channels in order to be fast, and we put an HDFS sync over here in order that you send it to the big data part. If you want to publish some of the information and sell it, you can put in CCAN, and perhaps some information also related to user or whatever, you can put in a relational database inside the MySQL part. This means that it's quite flexible, so probably, I don't know what problems you have, but Cygnus will solve it for sure. Some of them, you already have the configuration, and for others, you need to make just the configuration file. We can help you on this, and Andres can, sorry, no, he's not here today, but he can answer all kind of these things and via email or whatever way that you want to have. You can have, if not, some kind of other configuration. This is how the things looks like. We have the simple Cygnus configuration file. You have to declare, this is the ones that correspond to the model that we have seen before. So we have 3 different channels, the source, the signal, and the channel, and we define the different channels, the capacity. Usually the things if you are doing the processing at a normal speed, you don't have to have anything too quite complex. There are the definition of the different source, all the details on this. Also the details on the different things. This is the one that serialized to the HTTPS, or you can send to another place. There are different ways of doing the serialization depending on how you want to later process it. Usually they are done in JSON rows, or you can have JSON calls. It depends on the database you choose and how this is handled. In this case, HTTPS will handle, I think, it's a plain text files, but with the distribution that Hadoop needs, and we'll have it in this kind of way. As I tell you, we are now providing integration with Kafka. This is still ongoing, but you can start using it, and you are able to do some fast data streaming architecture. This is still under trial, but well, you can ask and try this kind of things. There you can connect the applications to a Kafka and then to the context broker, and then is the context broker to Kafka or whatever. You can receive things there, and later from Kafka or from context broker you can connect to Cygnus, and from it you can serialize the same way that we have said before. We have here the configurations, the high availability. Oh, I don't want to tell you that with Zookeeper is quite complex, but this is if you have a very high throughput, that you need a lot of instances from Cygnus and to have everything alive. As I tell you, we are doing right now a blockchain integration. Here we have a very simple smart contract that do these kind of things, and we are developing a Web3 connector that allows to send it to Ethereum context broker, the blockchain. Probably we will be able to give some on this quite soon. So this is the presentation that I was intended to give. I hope that helps solve your problem. At least you have to know what you have to use. I tell you the context broker you already have. Probably you need to have Cygnus or the short-term historic. You don't need to have both. I mean, you can have, if your problem is solved without Cygnus, I will say don't use Cygnus, use just the short-term historic. If your problem requires some kind of serialization, then use Cygnus and connect to whatever you need. And this way we can solve all the data, persistence, and all the things that you need or require. So we can move to the question time. I go back here with here the GoToMeeting. Any questions? I was too fast. I was a bit boring. Hello, is any there? Are you all asleep in siesta time?
That was excellent. I'm just going to steal back the screen. Okay, so this is where, again, like yesterday, you get to shine. If there are any questions, please start putting them into the chat. If not, I will start off with a few questions of my own. So the first question I have is, could you describe the correct use of the FIWARE header and how it's, or the FIWARE header and the service path header, and how it affects where stuff goes in the database?
Excuse me, I don't have the header of what you are saying.
The FIWARE service header and the FIWARE the headers on the request. When we
you mean, well, here everything in principle everything goes via the things. I mean, you're talking about Cygnus. Everything is serialized in the database.
Yeah, but when I have data coming in from an agent, I have a FIWARE service path and service header, and then
Yes.
how does the flow of data work from the IoT agent to Orion to
Oh yes, from the IoT.
how does
Yes, the
the
IoT.
header affect this?
Okay. These details is more under the one that control is. From my point of view, what you have there is that depending on the different entities that you have in the context broker, you have the communication from the IoT agent to these entities. The context broker, as I said before, is keeping the last value that is provided by the IoT agent. This means that wherever a value is changed, it sends a notification to everyone that is connecting to this value, to this entity. These connections are sent to Cygnus, and as I tell you, Cygnus is not very much intelligent. Whatever it receives, it just serializes. So it's the logic that is inside the context broker that decides where is everything going. So you relate your header to the entity that you are changing in your context broker, in your Orion context broker, and since Cygnus or STH-Comet are subscribed to changes in this, these changes are propagated to Cygnus or to the STH-Comet, and it's sent to them. Then they serialize them, and later you can do whatever you want with this kind of information. Take into account that what we have present here is the different persistence solutions. In some cases, we are making it more efficient, not just for persistence and batch study, but we are also in this phase of getting the fast data part. So this means that you will get the notifications quite soon. So you can have different components over there that could be reactive over the things that happens on the IoT layer. I don't know if I solved your question or if I've answered another thing. The chat. Yes, the Cosmos is online. We have a small problem that we were adding more computers. Right now, we have a small problems with OpenStack, but since last week, it's online, and which much computer power. I don't know how many cores. 100 more cores. No, I don't remember right now by memory the details, but it's online again and with more capability. Also, it's online. We are able not just to provide, even there still is not proper documentation on this. We are not offering just Hadoop and MapReduce. We are offering Apache Flink analysis that is mainly the event processing part, and also we are offering Spark Scala. If you know this kind of thing, you can send Spark Scala jobs and reduce ones. This is more simple for some people and more complex for another, but we can talk then later in Cosmos.
Okay, I have a
Yes.
I have another question. Feedback. Right. Could you mute your end for a second?
Yeah. No.
Right. Oh, you're still on there. I'll type the question instead. It's easier.
Okay. Well, there are some stress tests that have been done by the, let's say, the quality assurance group. I don't have the numbers here, but I mean, let's say something. If your application is not a real time with a lot of, I mean, you are not in a big data problem, STH-Comet is enough. I mean, if you have something that a usual in ODS web server can handle, I don't know by memory the numbers, but let's say that you are not in a very, very high number of communications, STH-Comet is enough. Just remember that it has a limit in the storage. It's not intended to have all the storage. I don't remember, you can configure this in the MongoDB, but there is one pre-configuration. But if none of you are having, let's say, problems like Twitter or one of these big platforms, probably you can go with the STH-Comet. Just that in that case, you get the things in the MongoDB. The MongoDB is there, is not intended to be accessed by you, but you can do it. And the idea is that you access via the REST API that you can do the aggregation or whatever. So if you are not having a real big data problem, STH-Comet will be enough for you. I can provide for the next day the exact numbers, but I say that it's quite high. But you have, I don't know, millions per second of transactions, probably not. But you are having 100 or this kind of per seconds or this kind of things, it probably will be able to handle. I will get the figures for next time. But there the limitation is more on the storage than in the processing. I mean, it's not storing all the data. If your data is changing a lot every second, probably STH-Comet is just well, depend on your window of your data. You just need the last day, for example, it's no problem on this. But for most typical sensors, STH-Comet is enough. And unless you have a whole, let's say, smart city sending all the information to one single STH-Comet is enough. Remember that you can have several STH-Comet. Since you are the one that are doing the registration to the different NGSI entities to the Cosmos, you can have several STH-Comet, one for one or more entities. You don't have, let's say, you have one or more Cosmos, and you have different entities there, and you are registering to listen to depends on the changing of these entities. This means that I can have several STH-Comet if I have problems on this. When you have several STH-Comet, then you have to have some coordination, and this is the thing I haven't told you about the Zookeeper. Zookeeper is a component from the Apache project that handles the high availability of different components. You have a protocol inside it in order to decide which things are alive and to keep everything alive. But this is for very complex scenario. For a simple one, I think that depending on the problem and the query you have to do with the data, STH-Comet will be enough. And if not, you can put several STH-Comets, one for each entity that you want to have. But I don't think that most of you have this problem.
Okay, do we have any further questions?
Sorry, but I have very bad memory for numbers. this and the projects also for Apache projects. There are something that my memory is not for numbers or for new projects. So, any more questions? Do you have enjoyed our streaming processing? You have think that it's much better to see me than just the slide? What is the feedback on this? Okay. It's better than a slide than a talking voice. Yes. Thank you.
Right, so if there are no further questions, we can wrap this up. I just want to thank Joaquín for giving his time to us today, and remind you that you can still use the usual methods to try and get any further questions. So thank you very much.
Okay, thank you. Bye.